Hi, my name is Ian Mars, and I am a master's student here at IUPUI. I'm studying geology, and I work in the experimental geochemistry lab. My research involves meteor impacts. In 2013, there was a meteor that exploded over Russia. It was sort of a popular thing on the internet for a while because all these dash cam footage videos came out, and there was this huge fireball streaking across the sky. Over 1,000 people were injured. These are dangerous scenarios. If there is going to be an impact, I think it's a very good idea that we know what happens when one hits the Earth. But also, the Earth isn't the only place humans will be. In just a few short years, in 2024, the NASA Artemis mission is going to take people to the moon again. The end goal, the next step after the Artemis mission, is to use the moon as a stepping stone to get to Mars. Those surfaces are, in some cases, entirely made of craters, and we should have a good idea, a good understanding of what impacts do to a surface so that we can survive on the moon and Mars to the best of our ability. If we had something like a piece of volcanic rock and it was impacted by a meteor, sometimes what forms are these. They're these things called tektites. What I do is we synthesize synthetic tektites. So we take powder, so we powder up a rock, and then we shoot it with a laser. We heat it up to very high temperatures to sort of simulate that impact. And that tells us a lot about what happens in the initial stages of an impact that are really hard to understand for us humans because they happen so fast and they deal with such high temperatures and pressures. Well, what we're hoping to find is an answer to sort of the mystery of meteor impacts, and that mystery is, why are these things, these tektites, why are they so rare? There are 190 confirmed impacts on the Earth right now that we know where the craters are. Only 4 of them have made tektites, and so that's clearly not a lot. These products are essentially eyewitnesses to an impact. This was there when the meteor impacted. And so it can tell us what was the temperature like, what was the pressure like, what was the soil made of at the time of the impact. And that's really what we're hoping to figure out with the research is, how do these things form exactly? Why do they form, and why do they form so rarely? It means so much to me that the NSF believes in the research. It means that they believe that there are implications for the work that go beyond just the study of impacts and maybe even just the study of geology. We have a lot of really talented people here, and I just wouldn't be where I am if it wasn't for those people in my lab, if it wasn't for the IUPUI faculty and the earth science faculty specifically.